Good morning, everyone. Today we are going to discuss about how radioactive particles and waves it will interact with matter. We know that radioactive material like uranium and thorium during the fission and fusion process, it can able to emit large number of radiation as in the form of particle as well as in the form of electromagnetic wave, and then after some amount of heat energy will be there. From the radioactive reaction or decay process, usually we will get this kind of particle like alpha and beta. So alpha is somewhat a heaviest particle, and then it have a 2 unit of positive charge. And similarly, there is another kind of particle also possible. It's called a beta, which means it's somewhat similar to electron. With addition, there is a electromagnetic wave also can be emitted from the nucleus. So these are some basic elementary particle we can found from the nuclear radio decay process. So here I just listed in what are the particle we can able to observe during the decay process. So we already discussed about alpha particle. It somewhat have a heavy mass. It carry 2 unit of positive charge. Similarly, protons. Individual proton particle also can be emitted. Neutrons, proton with some number of neutrons, like hydrogen isotopes, and then after beta particle like electron and positons. And similarly, there is uncharged particle like a neutron. It can be also emitted. So how these kind of charged particle or uncharged particle or electromagnetic wave, how these particle going to interact with the matter? We know that every matter it's have a nucleus and then electron. So we know that nucleus it's have a very high density of positive charge. Around that, some negative charged particle electron can be revolved around it. If we pass this charged particle or electromagnetic wave towards this matter, first the electron it will respond with the incoming particle or wave. If incoming radiations or particle have a sufficient energy, then it can able to penetrate through the nucleus or near to nucleus. So at the time of interactions, that means the radiations from radioactive particle, and then there is another side, there is a matter like atom or nucleus. While interacting with one another, we can able to observe these two kind of results from this process. The first case is ionization. That means if that charged particle or radiations from the radioactive decay process, if it is have a sufficient energy, it can knock down some of electron from the matter, which is revolved around the nucleus. So that process, the removal of some electron from the atom, it's that process called as ionization. So this kind of result, it's majority will happen in high energy charged particle. In case if a incoming charged particle or electromagnetic have a very less amount of energy, it produce excitation. That means it can able to transmit electron from one energy state to another energy state. That process is called excitation. So in this process, it can emit different wavelength electromagnetic radiations. Yeah, while discussing interaction of a charged particle or electromagnetic wave with matter, so this is one of the important term called a specific ionization. So we know that charged particle or high energy electromagnetic wave going to interact with some matter. At the time it can able to produce ionization. That means ions. It can able to remove some number of electron from the matter. How many pair of charged particle it can able to produce in a unit length, that's called a specific ionization. If a particle have a highest amount of mass and highest amount of charge, it have a highest amount of specific ionization. This means it can able to produce more number of charged particle. Okay, and then same time I just observe from the graph. Um, if a particle from the radioactive decay material coming from those kind of material, it may have a kinetic energy, and then it may have a charge. While interacting with matter, but it can it just interact with only through the kinetic energy. After passing through the some depth through the matter, it will lose all their kinetic energy and then convert their charge and mass into transfer to another material. So at that time, we can able to observe large number of ionization. So at the end of their path, if that particle lose all their kinetic energy, at the time we can able to observe maximum number of ionization. That's the maximum number of ions pair it can able to produce. With the peak called as a Bragg's peaks or Bragg's ionization. So it's one of the important parameter. In same way, there is another parameter. It's called a linear energy transfer. How much energy deposited per unit length by the charged particle. In previous case, we have discussed about how many number of charged particle. Here, how much of energy deposited per unit length. That's called a linear energy transfer. So it's also similar. Usually, the heavy particle have a high amount of linear energy transfer. So it can able to deposit more amount of energy in a short path. If a particle have a less charge or less mass, it have a very less amount of linear energy transfer capability. So we can compare different kind of particle or radiations and their capability to transfer energy. So there is alpha particle. It's have a maximum of mass and it also carry 2 unit of charges, positive charges. So it can able to deliver huge amount of energy transfer. That is another parameter because in a radioactive waves and particle, it have a different capability to interact with the matter. So how much distance it can able to cross or penetrate through the medium or matter. That parameter called as a range. Different radiation or different particle have different parameters. Like alpha particle, in first case, you just observe about alpha particle. It have a huge amount of mass, 4 unit of mass and 2 unit of positive charge. So it can easily interact with the matter. So by using thin sheet of paper, we can able to stop alpha particle. Then after beta particle, it's like electron or positron. It have a charge, but it have a less mass compared with alpha particle. So it can able to travel much distance in a matter. Thin sheet of metal can able to stop beta particle because it's our charge. It can easily interact with the metallic particle. And then after neutron, so neutron it have a somewhat heavy mass compared with the beta particle, but it don't have any charge. Due to their neutral property, so depend upon their kinetic energy, it can able to penetrate some more distance compared with the beta particle. In last case, it's a gamma. We know that it's just kind of electromagnetic radiation. It won't carry any amount of mass. It carry only energy. Due to that property, it can able to penetrate large quantity in a matter. So we have to use thin block of lead material to block gamma radiations. So these three property is required to understand how this electromagnetic radiations or radioactive particle can interact with the matter. The first one is ionization, specific ionization, and then linear energy transfer, then after range. Okay, thank you. further we will discuss in our next class.